So hello and welcome to another Bevy video. So today, like this morning when I woke up, Bevy 0.14 had just come out. Of course, everything is going wrong today. So I got home from work. I did read through most of this article before starting. I put a poll out asking if people wanted me to stream me going through this or not. And like at least half the people last time I checked had said yes. Bevy 14. So what's that entail? Well, apparently 256 contributors, so 1 byte worth of contributors, with 993 pull requests, which is just like mind-boggling. First up is our virtual geometry. They talk about this being very similar to Unreal's geometry in their default renderer. So what it does is it breaks up the geometry into smaller chunks, so you can have really complex geometry like this. And then each of these is like sort of what they call a meshlet or something. I think it's over here, like yeah, so the meshlets, and then so basically run it out of a sequence of meshlets, which allows for like basically dynamic meshing, where as you get further away, it will render less and less meshlets, which allows for level of detail to change based on distance, as well as like it cannot render all the meshlets on the far side, which means that you can have really complex geometry without it causing you to have to like render all this unseen geometry. They say to add it, you have to enable the features in Bevy and then also include the plugin into your game. And this is pre-computed. Apparently, it all has its own shaders and everything. But somewhere it says about you can use the builder or something, and you pre-compute this basically when you build application, and then when you run it's much faster again because it's all pre-computed at compile time. So it'll take ages to compile, but once compiled, it will run much smoother and faster with really high geometry models. And they just talk about the different shader inputs. Sharp screen space reflections, which just to me doesn't look very different. No, it looks the same to me, but I think that's kind of the implication. Oh no, it's the block. I was looking at the reflection of the building. The block is the reflection. Actually, that's pretty cool. It's even funny because the block's upside down, which means the reflection all up. I was looking at it going like the buildings reflected the background look the same. No, it's the block is there or not there. So this uses like ray marching or something to generate images, like 2D reflections. It samples the shadow somehow. I don't remember. I was reading to this rendering stuff is like all well beyond my depth, but really cool because it's something like you just add these 3 components here to your camera, and then suddenly you have reflections in water. So that's cool. And I think they also said there's a whole bunch of things like you can change the like level of detail and stuff like that depending on how much of your like compute you want to go to just working out the reflections. It's from the people that make Tiny Glade, which is like a really cool looking little indie game where I think it's like waveform clap style, like you build the environment and based on what's next to things, they connect together. I think that was Tiny Glade. It looked really cool. Like I saw a Reddit post on Tiny Glade and I was like, that is such a cool thing to be making with Bevy. It doesn't use all of Bevy. It's like they've taken like the ECS and pulled it all out, and like they're using Bevy how like Bevy was described, like you can do this, where instead of using it as the engine, they're pulling the parts that they want and then building their own engine out of the parts. So that's pretty cool, especially considering they're contributing back like this cool stuff. So next up, Volumetric Fog, which is amazing. So you get like these God rays. So because it computes the fog, this is definitely ray marched. Somewhere it said about ray marching. No, can't find it. But it basically just means that instead of treating your fog as like as you get further and further away from the camera, the fog gets thicker and thicker. It actually can compute things like the fact that the light is coming through here, so this gets lit up better than this because there's a tree blocking it, allowing for God rays. And it's all they've gone real heavy into artistic design, where like a lot of these parameters are configurable. So I'm assuming like fog density and stuff like that, all configurable, and fog settings. That's the word I'm looking for. So it's pretty cool. Looks really nice. Like what's going to be great about this is like if I get my Minecraft clone, like I can just turn the fog on and it will add just a whole cool effect without me needing to like compute and calculate fog and like work out all the stuff myself. Like the default stuff that Bevy includes now is just phenomenal. So next up, per object motion blur. This is basically just a change so that the motion blur is applied like per object. I think it's a component you add, yes. So motion blur bundle onto your camera, and then it does this. So basically what it's saying is if the camera's moving with the car doesn't motion blur, the trees motion blur, but when the car moves past, it will motion blur that. They explain it much better up here, but it's basically just that it's relative to the camera's position, or like relative to the camera's view, not necessarily to the position of the camera. As in, these trees aren't moving relative to the camera, but they're motion blurring, whereas the car is moving relative to the camera, but because the camera's following it, it doesn't motion blur. It's also tied to the frame rate, which means that really high frame rates don't get excessive blur or something. They aren't subject to over blurring. High refresh rate. Yeah, so it calculates it based on the camera's shutter angle, which is to do with the frame rate of the camera. Which, for some reason, Bevy's going in the direction of like treating the camera that the game's viewed for as like an actual real camera, because you can change the aperture and you can change the f-stop and stuff to get like really stylistic design and view, which, you know, is all part of developing something like this. But I just find it weird that it's becoming more and more like they're actually like simulating a real camera, especially considering like, you know, calculating shutter angle and stuff. So then we got Filmic color grading, which, to be honest, not really sure. I think it's to do with making like your lighting and your white and they like look like white. So you put like your white there and you can tweak all these values until the white looks like your white, and then you know, make all the other colors warmer or cooler. You know, it's all controllable at highlights, tones, shadows, and you can tweak these all individually to give you like the stylistic design that you want, like really dial in on that, like looking like a movie kind of thing. So this is one of those things is like I don't think a lot of general people use as much as like they're making Bevy for like if lighting is your thing, you'll love this. Or if you're in a professional setting where like you're actually hiring someone whose entire job is to make the pictures like make it look great, they will understand all this terminology. To me, this is a lot of like I kind of get what it's talking about. Like there's exposure and temperature and like tint, hue, and gamma. So like these are all things like I kind of know what they do, but not enough to be like, oh, I know I'd like to tweak this image. I know exposure will make things brighter because it's exposure. Temperature changes like the blue redness of a light. Like a really high temperature light will be already white with it like a tinge of blue, whereas a low temperature light will be quite orange, like this image here where it's like basically it's orange. Hue is just, you know, through the color wheel shift, and then tint I'm assuming is just another thing again. But yeah, it's one of those I don't really know enough about lighting to explain this well. Auto exposure, this is something that's kind of cool. So Bevy let you change the exposure of the camera, which would like basically, you know, you can make dark rooms really dark where only the lightest things can be seen, that kind of thing. And now they've got an auto exposure that lets you like dynamically change how much is visible. So as you can see here, like when they look at something bright, you can't see it, and then the auto exposure comes down and you can actually see the image, but everything else goes black. Look away from it and the auto exposure goes back up until you can see the difference in like shades of green again. So I think they do talk about like it's not really intended to just be used by default. It's off by default, but instead to be used in very specific places where you're trying to get a desired effect like that, where when they walk into a dark room, they can't see anything because they were just somewhere bright, and then it slowly adjusts in. You could have like a survival game where you use this auto exposure so that they can't see when they go from bright to dark and something like that, or like, and then when a flashlight gets used, like it can blind people or like that kind of thing. Could have really cool effects that can be used, and you know, all built into Bevy, so no need to program it all yourself. Fast depth of field. Basically, depth of field is the idea that things in the background can be out of focus, things in the foreground can be out of focus, and only the things in the middle are in focus. And so now they've implemented that. They said the default's a Gaussian blur, which is fast, but you know, not the best looking. And then they've got Bok blur, which is where the blur like looks like the shape of the aperture of the camera, which means in this case they're using a hexagon. And so if there was like a point of light here, it would be a tiny hexagon because it blurs into a hexagon. And you can actually, not with Bevy, but in real photography, you can actually make that like do whatever shape you want. So you can have like lots of lights out of your depth of field through like a pinhole shape of like a tiny elephant or something, and then all the little pin pricks of light look like tiny elephants. It's actually a really cool photography technique, but basically Bevy's implemented it so that like you can have your depth of field look really cool. This is that the PBR Anisotropy. So the idea is that this is what your normal specular highlights would look like, just points reflecting light. But what Bevy's done is means that because this is sort of like brushed this way, like it's been polished that way, the light actually sort of scatters up because it scatters more up and down than it does left and right, which makes a sort of a narrow width and a tall height, which gives the appearance of a line through it. And yeah, so you can just do that now. So this is again more really cool lighting. Like it's a lot of this update seems to be quite visual based, but some of this stuff I'm also just like super excited to try my Bevy Through the Ages and just like add the 0.14 update to it and see how much faster this is. I haven't seen anything talking about the performance improvements, but I'm just hoping that there's some stuff in there that was like, yeah, it was just so much faster. So what else we got? Percentage closest filtering. So this is, I think it's an anti-aliasing technique to just make shadows smoother, so you can see here all the dots, and then there you go, this, and it's like more blurred, and it's basically saying that they sample like there's something about a kernel somewhere. I saw it somewhere. They're sampling basically like a square of pixels around that pixel, and then taking the average of that to work out what it should be, which means that you sort of end up with smoother edges rather than sharp edges where the light suddenly stops. Instead, yeah, you sort of end up with a nice blend from light to dark. There's a subpixel morph anti-aliasing, which is again like it's. I wish I knew more about rendering, but like yeah, so it's just anti-aliasing. What type of edit? So something like subpixels. So it must anti-alias just like on a smaller resolution. Subpixel. Okay, so it's just another form of anti-aliasing. I really don't know how it works. All right. Visual range. So this is one of those things that like I'm like, oof, this will be great for some games and hopefully like like Minecraft clone, that kind of thing, where Bevy now has built-in features for level of detail. So I don't know how to use it because again I don't even have videos or pictures, but it basically just means that based on the range the object is away from the player, the further the object is, you can make it swap to a lower resolution mesh beyond a certain distance so that you don't render really high resolution stuff that nobody can see the detail of, which for my voxel game would be kind of cool because you could like you could generate like a few different chunks, say like you generate like the full depth, full detail chunk where every block is rendered, and then you do one where only the even blocks are rendered, and then you do one like where only every fourth block is rendered as filling the same space as the 4 blocks, and then pass that off. So it's like when it's so far away, you'll only render it like a quarter of the blocks because it's not going to render the stuff that you won't be able to make out the detail of, and it should look really good and increase view distances without necessarily decreasing performance. Onto the fun stuff now. We've got hooks and observers. So Bevy had a pull style of events. So the idea being that the events are queued and you go, hey, I'm ready for my events, and you take them down. This is the fast method, but has some overhead. But it does mean that like you only process events like when they're ready, rather than like waiting for something to send your events. But hooks and observers are sort of the opposite of that. So they process events immediately because it's like a push style. So when the event happens, they push the event to be executed right away, rather than waiting till like the next frame for the system to come in and be like, okay, let me process these events. So slightly slower, but doesn't have the overhead of having to constantly check to see if everything's ready like to be processed. But the big advantage is, so they talk about it down here, is the life cycle hooks. But so hooks are specifically programmed like much more restricted in what you can do with a hook, but much faster and better executed because the hook is more restricted, so they can add optimizations. And an observer, like you can literally write like basically a query that whenever the query gets true, like the hook, the observer runs. Or whenever the event's just pushed, like if you just say like, oh, this person joined the server, it's like the event runs. So hooks tie into the component lifecycle in that you can now implement a component yourself, and you can say, hey, when this component is being created, like I want to add an on remove hook, which means that when this component is removed or the entity that this component is attached to is despawned, I want you to run this piece of code immediately. So their example here is that you have a target and a targetable. And so the target here can pick an entity that's targetable, and then it'll add itself to the list of targeted, like who's targeting this entity. And then when you despawn this targetable entity, which would be like the player's targetable, and every enemy has a target that they're going for. When you despawn this targetable, it will then go through all of its entities that it's targeting, or that are targeting it, and unassign them from targeting anything. Which means that, like, if a bullet hits the player, then suddenly all the bullets are no longer targeting the player, or all the enemies stop targeting the player. Which is like a really cool way of doing this, because like there was something I was trying to implement where this would have been really useful, is to have that ability to like, I think it was like loading a scene or something, is to have that ability of like, when the scene is loaded, I want you to go find this thing, like say like when a chunk mesh is spawned, or like when an entity inside of a chunk of other entities spawned, I want you to go find the parent chunk, instead of me having to spawn you inside the parent chunk or the world entity. It's like whenever I spawn a chunk in, I want you to automatically find and set its parent to the world. So that's something that's going to be really cool to do. And its observers are just the same thing again, but like on a much more unrestricted way. Like you can just send a message, like so like world.observer, and then the trigger says that when you send it a message, it just prints the message, and then you can just, in any system, send and trigger the message. So that's pretty cool. And it happens immediately, which means you don't have that 1 frame delay, or the risk of a like system missing an event because it didn't run every frame and the events are cleared every other frame, so it missed events. GLTF texture transform support. So this is just an expansion on GLTF to include it can now like apply transforms. So I don't really use GLTF much, but it just means that like more of the GLTF format that you can export from Blender, and that is now brought into Bevy and actually respected. Like you can morph a texture before applying it, I guess. See, like this, so the bricks, and then you're saying like scale them down. So basically it automatically scales it down because it knows this now. You can now radius the corners on a border. So all left, right. So this is so this is with a border, and then like the top left is radiused. Top, bottom, top. So basically, just it allows you to specify a border radius, and then you can do all that cool stuff. You can now do animation blending with the animation graph. Again, I haven't really read this much because I didn't quite get this far, but it just seems that it's like you can like just expand on top of the animation. So you load this clip, and then animation graph.add clip loads another clip. So I think these are sort of chained, and then they must blend together. So the improved color API is that Bevy, I think, now represents everything as linear RGBA, and then implements a trait on top that implements the trait hue and alpha for the types that use that, allowing for a much better like easier time using the functions of a data type, because if it doesn't have like, so instead of having the color struct that they had that then like had a color and then sRGB, and then having your hue, saturation, lightness, like instead of having those as enum variants, now they're their own struct, and so you don't have to have a hue option on your sRGB, because sRGB doesn't understand or respect the concept of hue. That's a hue, saturation, lightness concept, and so you only implement hue when the color space actually allows for hue shifting or hue measurement. Otherwise, I think it don't know if it's here it mentioned or later on. It says like you have to convert to a different color space, change it, and then convert back. And maybe it's something else. It had a hue option, and if you change the hue option, it converts to one color space, shifts the hue, converts back. And this, I think, just makes it slightly more clear. But so like you can also have things like mix, and I'm assuming mix will take in anything with a color, because you can just convert the color to sRGB and then mix them and then convert them back. Like, but at least made it so that like the colors are more versatile and useful for people wanting to use their color space rather than a custom color space. Okay. Extruded shapes. So Bevy's 2D shapes can now be extruded out into 3 dimensions like this, and you can also like query things like their bounding box, their volume, their area. I guess this must be something that they added in the previous one, that you could measure 2D, and so you must be able to query its area and perimeter and stuff. But now you can sample its volume if it's 3D, and you can extrude 2D shapes into 3D, which is pretty cool. They've added more gizmos, so now there's like a corner chopped out gizmo and a rounded corner gizmo, grid gizmo, which will be really useful for things like my voxel based game. So, because then you can render the chunk boundaries as a grid rather than having to just sort of know where the boundaries are. There's now an coordinate axis gizmo, lighting gizmo, which is neat. So that, I guess, is like your point light and your directional lights now have like a gizmo, so you can render them and see them. And I'm assuming this is probably like a spotlight, maybe this is a spotlight. This might be a directional light. I don't know what the yellow one is. It's not seeming to light up anything. It must be a directional light, and it's because it's in front of these blocks. It's not lighting them up. Gizmo, line, style, and joints. So you can render lines and just tell it how it renders around a corner. So like this one is just, I guess this must be mirror, and then this one's rounded, that one's chamfered, and this one's something, I don't know. I guess this would probably be none, and this would be the bevel, which is actually a chamfer. But anyway. And then also there's a UI node gizmo, which just draws an outline around the UI node, which is kind of cool. Useful for debugging, not so useful for actual game situations, but it lets you implement like Minecraft's F3 menu and stuff like that. So, there's use cases for it. Okay, and then context clearing gizmos. So basically they said that instead of clearing once per frame, I don't actually know what it clears on now, but it allows you to use custom schedulers instead as well. So I guess this means that like you can have gizmos that aren't necessarily re-rendered every frame. So like the way that gizmos work at the moment is they're immediate mode, which means that you have to say every frame render this gizmo or it doesn't render. And this, I think, is saying that you can now say like these are gizmos that need to be rendered every frame, and it's like, but the colliders, they don't need to be re-rendered every frame. They'll just stay on screen. Like you don't have to tell every frame every time a frame happens to render it again, which will be good for like my Minecraft clone. The big thing that it ran really slow when you turned on the collider visualization, and it's like part of, because it was every frame it would be redrawing these gizmos and recalculating all the gizmos, whereas this is like it'll draw them every frame, but it doesn't recalculate them because it's not immediate mode anymore. So you can say when clear all the gizmos and when not to clear the gizmos, but also have different sets of gizmos that can be cleared and not cleared. So yeah, that's cool. Query join. So this allows you to have 2 queries, and you can join A and B, and then you'll get a new query that only contains the items that are in both A and B. This allows you to basically do like 2 small queries, or like a big query, and then like a sub query, like with some other thing, and then you can have your big query, do something with it, and then be like, okay, and now I just want to filter out everything else, so it's just got the smaller query, but also all the stuff in the big query, and so you can do really cool like it's like mixing and matching of the query, like where it does both sort of thing. It also appears that you can extract the entity without necessarily querying for the entity here. Like you can have A, have B, and then you can query it and get the entity as well. But that'd probably always be something you may have been able to do. I'm not sure. It's just interesting that the signature changes like that. So now we're on another one of those exciting ones. This is computed state and substate. So basically a computed state is like a state where you can have multiple states that may be classed as in-game. So your in-game paused whether you're paused or unpaused, you're still in game, so that can trigger the in-game state. You may also have a whole bunch of other things. The example they give up here, which is better than the in-game state that I'm trying to give, is in menu. So you may have a main menu, a pause menu, but all of them will trigger the in menu state, and then you can have logic that only runs when you're in a menu. You can only have logic when you're in game, and all these things happen. And so that's like a computed state, and then there's substates, and so substates are like states that are only implemented into the game while you are currently like in another state. So like this setup, battle, and conclusion are only a valid state while you're in game. Otherwise, they don't exist. So you can actually rely on the existence of this being a way of like determining certain logic of your game. This macro means that game phase will only exist when in game computed state. So you don't have to check if every possible state that could flag you as in-game exists before you remove this, because you've just like the computed one will determine that you're in game, and then this will determine which phase of in game, instead of putting the game phase inside the in-game struct. Like it's a way of like splitting everything apart so that Bevy manages which states enter and exit of things. And I'm pretty sure like I mentioned this and was talking about how this works and like how this could be difficult in my states video. So it's nice to see that I wasn't just like talking about my ass. Like this is something that Bevy was looking into. And then to initialize it, you don't initialize the state and then the compute state and substate. Like you just initialize them, just like any other state. They have a non-exit next state. And here's another thing that I think I mentioned in it. No, this is something I mentioned. Maybe this is something I think I did in my Minecraft clone. Maybe is state scoped entities. This is like when you enter into a menu, all the menu items can be state scoped so that when you exit the menu, they'll get despawned. In this case, they're state scoping it in game, which means that when you leave in game, it despawns everything that was in game. And it just means that you don't have to write those tacky cleanup functions and systems that I have to write whenever I'm doing something like a menu where it's like, I'm like, hey, this is what the menu is called. And every time I spawn stuff in that's in the menu, I tag it with like a menu thing. And then when I leave menu, and then you have to remember for every menu to add. So this is like, hey, you can just say to it, like, when you exit in menu, you delete all the menu related things. And then you can then have each of your different menus all set the game state as in menu. The computed state as being in menu. So it's a really good like boilerplate cutting down thing of like making it much easier for say like an API level plugin, like if Belly ever got updated, which I don't think it will, but if it got updated to 0.14, like it would give it the flexibility of being able to provide you like, hey, mark it with this and we'll take care of clearing it when it's done. And Belly doesn't have to actually track anything. It can just set up all the correct things, which is pretty cool. State identity transition. You can change whether a state will trigger a on enter when going from itself to itself. So that's cool. Like again, it's more like flexibility for people that want to really speed up my my Bevy. Maybe not though, because I think I specifically avoided any frustum culling in my tests, but GPU side frustum culling, which is just basically the camera has the what the camera can see, and then you go a little bit further than that, and anything outside of what the camera can see, you don't render. So that's frustum culling. The frustum of the camera is what the camera could possibly see, not necessarily what it does see, but what it could possibly see, and then you just cull that away. Anything that's outside it, there's no way the camera can see it, so it's gone. And then the GPU side frustum culling means that instead of your CPU having to go through everything and going, hey, can I see? It just sends it all to the GPU, and the GPU then goes, hey, can I see any of this? What of this can I see? Okay, so this is another one of those, like, I don't think I've ever actually done this, but you can send commands when you have mutable world access, and they're saying is what you had to do in the past is you had to create a commands queue and then generate the commands component and then run your commands like you would in a normal system. But now they're saying like if you just have access to the world, you can just say world.commands, the commands to spawn. Like it's now just basically like wrapped inside a convenient function. They've reduced multi-threaded executor overhead, so that's nice, but I don't think that changes much unless you've got a lot of threads running. So they've also apparently decoupled background color and UI image. UI images can now be given a solid background color, right? That's nice. Background color. Yeah. So I think this is just something that if you're needing it, it'd be really, really good, but otherwise not noticeable. Combined WinInt events. Okay, so what they're saying is instead of they now expose the raw WinInt event rather than, well, they probably also still split it up. So it used to be that you could track the mouse movement and then you could track drag and drop events. But they're saying like you needed to know exactly when the drop event happened so that you don't keep tracking mouse movements after it's been dropped. So now they're like the WinInt event will actually export the whole thing so that you know exactly what the last mouse movement was before the drop event happened. So that's fun. Recusive Reflect registration. Okay. Process data, things like serialization, deserialization. Bevy has the type registry to keep track of which types exist. Users can register their custom types. Okay, yeah. So we can register custom types. So I suspect what this is saying is that if we say register type, that's fucking incredible. Like, yeah, how many times I've been registering types. So basically, what they're saying is in the old Bevy version, you used to have to register your type, and your types, data relies on blob, so you had to also register blob, and then blob obviously contains a vec of U8s, so you had to register vec of U8s as well. Now, when you add it, it will register all the dependent, all its dependent types, and then they will register all their dependent types, which results in you only having to register the one thing, and then all the required types will be registered. This is great because there's a few things that like there's small things like the Bevy editor please had a couple of crashes that I know about, like when you tried to serialize something or save the serialized file, it would crash because some type was not registered. And it's like, well, now if you register the camera, then all of the camera's components are registered, which probably still wouldn't help with those crashes because I'm pretty sure they were just individual components. But it's to say, like, it means that no sub part of a component will be missing from the thing. ROT2 type, ROT2 type for 2D rotations. Okay, so I guess it's just to do with like rotations. Instead of just using a F32, you can now use ROT2, which I guess represents it as a quaternion. Okay, alignment API for transforms. Okay. There's a new transform align function, which is a more general form of lookat, which allows you to specify any local axes you want to use for the main and secondary axes. Okay. This allows you to do things like point the front of a spaceship at a planet while keeping the right wing pointed in the direction of another ship, or point the top of the ship the direction of a tracking beam pulling it in, while the front rotates to match the bigger ship's direction. Okay. So it allows you to specify more details about the axes when you put it. Okay. Random samples of shapes and direction. Basically, you can sample a random number and it'll be within a triangle, sample a random number, it'll be with a square, circle, rectangle, whatever this thing's called. I want to say pill, but pill's not right. It's got a fancy name. Tools for profiling GPU performance. Okay, cool. Timestamp queries, pipeline statistics. So basically, if you're trying to benchmark stuff, Bevy now has features, so that's cool. New geometric primitives, rhombus, arc 2D, which is like a segment of a circle, triangle 3D, tetrahedron, okay, annulus, circle segment, and circular section. Improve point and rename it to vector space. I'm just going to start speeding up because I think we're like halfway through and this video will already be like an hour long. So that's always fun. So 2D mesh wireframes. So then basically you can now render wireframes for 2D meshes, custom, reflect field attributes. Field.get attribute. Okay, so it's like an attribute that's actually encoded, so you can reflect an additional piece of data attached to this, and then you can request that additional piece of data. So like additional, like, so you could reflect a name, and then you could request the name. And okay, so that means it must still be stored like in data, so it's like not related to the type, but important to reflect on how it's going to use that type. Hey, just start. Oh, the Bevy editor when it comes out is going to be amazing. I mean, even just doing that, so the Bevy editor please has an easier time implementing and maintaining its editor is going to be great. Query iteration sorting. Bevy does not make guarantees about the order of items, so if we wish to work with query items in a certain order, we need to sort them. So basically they're saying you had to collect all of the entities from the query and then use them. So you can sort and iterate and then do other things like filter it. Do keep in mind that lenses add extra overhead. Obviously they do, because you're doing more with the iterator. Like you've got to at the very least like iterate through it to sort everything. There's more overhead. You can't just use them willy-nilly. You gotta make sure you only system builder. Bevy users love systems. Yes, we do. Okay, this is gonna make scripting amazing. And that's all I'm going to say, because that looks complicated. I'm just going to move on. Throttle render assets. So what they're saying is you can sort of set how much memory can be sent to and from the GPU in any one frame to stop the GPU from having to wait for all the memory to finish transmitting before it can render a frame. And they're basically saying that this may result in it being a couple of frames before something renders because it needed to wait for all the data to come across. But this is favorable than the game stuttering because memory is getting set across, and most people won't even notice that something popped in a couple of frames late. Standard material UV channel selection. I don't get it, but okay. I'm sure that'll be useful. Removed limit on render layers on unimplemented diagnostic. Okay, that's really cool, because that's something that's been shitting me off sometimes with Bevy, is that like if I haven't used it in ages and then I start using it, it's very easy to mess something up and just have it like spit out an error that I'm like, what is wrong? Like, what am I doing wrong? So the fact that like now it's entirely possible to have an error message that like we actually can go like, hey, I know what this error message is. Motion vectors and TAA for animation meshes. Improve matrix names. Typed GLTF labels. We can say load GLTF load scene from asset. So basically, like you can now specify what part of the GLTF to load, and then pass in the file. So that's this. Resource entity map. Melting my brain. So basically, the way Bevy had it is if you saved a scene, any entity references in that would be changed so that they point to the appropriate entity in the save scene, and therefore when you load them, an entity pointing to a specific other entity is not going to have the same entity anymore, so it would change which entity they're pointing at so that that's correct again. And it only applied to components, but now it can be applied to resources. Compass quadrant, compass octant, support async seek when loading assets. So it lets you not have to process every single byte of a file in order to render, to like load assets. You can like skip the first bit, which is probably why a bunch of the GLTF stuff now works, is that they're using this to be able to like skip around the file a little bit more easily, which is nice. Okay, load status failed, now has error information. Okay, that's nice. App exit errors. I guess the apps can exit with error codes now. Deprecate dynamic plugins, because so basically they said nobody's using it. There's not much done to it. So if you are using it, maintain it yourself. What's next? Better scenes. Okay, scenes is one of Bevy's core building blocks, designed to be a powerful tool for authoring levels. But okay, ECS relations. Better audio. That's gonna be cool. Contributing book. Curve attribution. Better text. A unified view on DevTools in 0.14. We added a stub Bevy dev tools, create a place for tools and overlays that speed up game development, such as performance monitoring, flying camera. Ooh, yay! Flycam will be part of Bevy, like actually maintained by the developers. I'm so sick of having to try and having to implement a flycam in every single game that I make because the official one doesn't get updated anymore. Or like not the official one, like the crate Bevy flycam doesn't get updates quickly at least. It seems like the dev tools is going to be like sort of like just all the little bits and pieces of tools, maybe from the community and whatnot, that they've put in places like the Bevy editor and stuff like that. It'd be nice to have them all in one place so that you know they exist more than anything, because I usually stumble across them when I'm looking on the Bevy assets or doing something else where it's like, oh, this exists. Bevy remote protocol, a modular maintainable render graph. Thank you to anyone that watched that whole video. That was a really long update. And double thanks to anyone who watched the live stream. I am going to probably not edit this today.